Question 2, we have been given fxy equals to 1 divided by a times 1 to the power of 2x, and we also know the range of x and y. Y is larger than 1, and x is ranging from 1 divided by y to y. So the first question is, we should draw the non-zero definition region of x as y. Then we have to use some baselines, since we know that y is bigger than 1. So we should have a line which means y equals to 1. That is the baseline 1. And baseline 2 is, since x is ranging from 1 divided by y to y, we should have two lines. One is y equals to 1 divided by x. And that should be look like this. And the other is y equals to x. And that should be look like this. So in this case, when we have to figure out the non-zero definition, we have to use the intersection of them, and that should be the shaded area. And that's the answer of the question 1. We have already given it in the drawer. Then question 2. We have to find a so that fxy is a valid joint density function. In order to find a valid joint density function, we have used the definition of the validation, that is the integral of xy dx dy equals to 1. And in this case, we should do the integral from 1 to infinity, and 1 divided by y to y, 1 divided by a times 1 to the power of 2x dx dy equals to 1. And in this case, we can simply do the integral from the first inside part. Then we got integral from 1 to infinity, 1 divided by a times 1 to the power of 2, and then the ln x, 1 divided by y to y dy equals to 1. And then we have the integral from 1 to infinity, 2 divided by a times the integral from 1 to infinity, ln y divided by y to the power of 2 dy equals to 1. In order to calculate the first part, we have to do some shifts. That is, we simply use u equals to ln y, and in this case, y equals to e to the power of u. Then the left part just become 2 divided by a, the integral from 0 to infinity, u divided by e to the power of 2 times u, d e to the power of u, and that should be 2 divided by a, integral from 0 to infinity, u divided by e to the power of 2u, e to the power of u du, and that should be 2 divided by a, the integral from 0 to infinity, u times e to the power of minus u du, and that should be minus 2 divided by a times u times e to the power of minus u from 0 to infinity minus the integral from 0 to infinity e to the power of minus u du, and that is simply 1. So in this case, we know that 1 times two divided by a, and that is 1. So in this case, we already know that a equals to 2. And that's the answer of the question 2. Then in question 3, we have to find and draw the marginal density function of fx and fy. In this case, we have just used the definition of the marginal density function, that is the fy equals to from the integral from minus infinitive to infinitive fxy dx. And we already know the range of y, and that should be 1 divided by y to y integral 1 divided by 2 times 1 to the power of 2 times x dx, and that should be ln y divided by y to the time of 2. And that is the marginal density function of y when y is larger than 1. As follows, the density function of x should be the same flavor. That should be integral from minus infinitive to infinitive fxy dy, and that should be the integral from x to infinitive 1 divided by 2 times y to the power of 2 times x dx, and that should be 1 divided by 2 times x to the power of 2. And that is when x is larger than 1. And when x is ranging from 0 to 1, we should have fx equals to the 1 divided by x to infinitive integral 1 divided by 2 times 1 to the power of 2 times x dy. That should be 1 divided by 2. And now we know that both the marginal density function of x and the marginal density function of y. In the last question, we have to verify the fx and fy are valid density functions. In this case, we have to use the definition of the validation, that is the integral from minus infinitive to infinitive fy dy equals to 1, and also the integral from minus infinitive to infinitive fx dx equals to 1. Now we can firstly figure out the left part of this. We can use a star, and the star equals to the integral from 1 to infinitive ln y divided by y to the times of 2 dy. And we have already figured out this calculation in the first question, and we simply know that the inside part should be 1. So we have proved the validation of the density function of y. Then we can prove the x. The star primes equals to 2 parts. One part is ranging from 0 to 1, and the other part is simply x is larger than 1. So we have to use 2 parts of integral. That is, one part is the integral from 0 to 1 half times dx plus the integral from 1 to infinitive 1 divided by 2 times x to the power of 2. Unfortunately, the answer should be 1, 2. So in this case, we have proved both the marginal density function of x and y are valid. That's the question 2's answer. That's all. Thanks.